For point A, we need to find the restrictions in the domain. And well, because our function is polynomial, we don't have any restriction. And because it's polynomial also, the domain is from minus infinity to infinity.
Okay, in the point B, we have to find the x and y intercept coordinates. And to find the y coordinate, we have to substitute x to 0. So we substitute x to 0 in here, and the final point is 0, 0. And to find the intercept in x, in the x-axis, we have to substitute y to 0. So we substitute here, and we have to find the common factor. This is the common factor of this one. And one point, this point is 0. And to find the other point, this point, we have to isolate x. So we isolate here to x squared equals 0 equal 3, and then x equal plus minus root of 3. So the 3 points are a 0, 0, b root of 3, 0, and c root of minus 3, 0.
Now we have to find the symmetry with residual. So to find the symmetry, we're going to substitute all the x with minus x. So we substitute in the formula, and we got minus x to the third power plus 3 times x. Now we have the common factor that is minus, so the final result is minus times x to the third power minus 3 times x. So like this function is equal to this function, we have an odd function with symmetry.
For point D, we need to find the vertical asymptotes and the gaps. So this is our function, and well, it is a polynomial function, so we don't have vertical asymptotes, and also we don't have gaps.
Okay, in the point E, we have to find the horizontal asymptote using all needed procedures. So this is a polynomial function, so we know that it doesn't have horizontal asymptotes.
Now we need to find the first derivative, so our function is x to the third power minus 3x. So to get the first derivative, we're going to multiply the 3 times x to 3 minus 1 minus 3 times x to 1 minus 1. So the final result, our derivative is 3x squared minus 3.
For point G, we need to do this. We have our first derivative of the function, and well, then we take out the x from the function, and we have our two critical points, 1 and minus 1. Then we see the rule for the maximum and the minimum points, and well, we substituted these points, these critical points, in our second derivative, and we have as a result minus 6 and 6, and following the rules, minus 6 is the maximum and 6 is the minimum. Then, with our two critical points, we substituted in our original function, and we got the points for y, and then we have our 2 points for the maximum and for the minimum. Then we need to find the intervals of decreasing and increasing, and we do our table. These are our two critical points. We have a value behind and another forward, a value behind and another one forward. Then we substitute these values in our normal function, in our first derivative, sorry. And then with this, we have our two points where we could see the increasing and the decreasing points. So these two are for the increasing, and this one is where the graph will decrease.
Okay, in this point we have to find the second derivative, and this is the first derivative. So we multiply 2 for 3, we have 6x. This is the second derivative.
For the concavity test, we're going to use the second derivative and isolate x. So we got that x is equal to 0. Then we are going to give 2 points, minus 1 and 1, and these are going to be substituted in the second derivative, and we got minus 6 and 6. So the concavity intervals are 0, to infinity and minus infinity, 0. Then to get the inflection point, we're going to use the third derivative, and following the rule, we got that the inflection point is 0, 0, and we can see it in the graph because first is a downward concavity, and in 0, 0 it changed to upward concavity.